Let's begin the review. So, hello everyone. Hopefully you're doing well. You're excited about tomorrow. So let's actually just get to it. So it's more of a Q&A session. Hopefully everyone here has gone through the review for the final that was posted online. So at this point, I will kind of leave it to you guys. I will take questions on anything for the next hour or so. So take it away. This is where you guys coming.
You can ask question.
Yeah.
Could we ask the mock final solution?
Sure.
Do you have a solution for the mock final?
No, that's why we're here right now. So
fine.
If there's anything you tried and you're not sure about, we can talk about it.
Okay. What about a question 5? The Jhevon cliff. Oh no, question 6, the motion problem.
Question 6, the motion problem. Okay, let me look that up. Dun, dun, dun. All right. So hopefully you guys can see that. There is question 6. And I guess I can turn off the video for now. So you guys will only need to see me here. Need to see me. Okay, all right. Yes, so question 6. All right. Yeah, so you want to tell me how you started? What did you try?
I tried from the a equals -32 and integrate the.
So a of t equals -32. This means that your v of t would be equal to?
-32t plus c.
Yes.
So we automatically think that when t equals 0 and velocity equals 0, right?
Right. So dropped means you weren't thrown off with any speed. So dropped means initial velocity is 0.
Okay.
And of course, so that means that v of 0 is 0, which is -32 times 0 plus c, which means that your c is 0. So your velocity function is just -32t. Right. Now?
Integrate the v of t. So.
And that gives you position.
Yeah.
Which is -16t squared plus a constant.
C. Yeah. So when the Jhevon hit the ground at a speed of the 160 feet per second, which means that we can plug in the 160 to calculate the time, right? It is 5 seconds. Or I don't know what.
Yes. So you calculate the time. So you mean from up here then? So we know that final velocity.
Yeah.
Is we want -160, right? It's 160.
Yeah.
And it's minus because it's moving down. Because this is downwards.
Yeah.
So set this equal to -32t, and we're setting this equal to that to figure out time. And so this means t is equal to what here?
5.
5. Which means I know that s, if I plug in 5 into s, that would be 0 because I know I hit the ground.
Oh, okay.
Right? Ground is at level 0.
Okay. Okay.
And so now that would be minus 16 times 5 squared plus c. And this means your c would be equal to 16 times 5 squared. And that happens to be the height of the cliff.
$400.
Right. Because your s of 0 would be that guy. So
Yeah.
that's it.
Okay.
So these are two phrases, and if you've done physics especially, you'll be used to these notions. But something like dropped or released kind of means initial velocity is 0, and you normally think of the ground level as being position 0.
Mm-hmm.
And so you would fill in 0 here, and you would also fill in 0 here.
Okay.
Yeah. Okay, so that is problem 6.
Mm-hmm.
So I'm guessing this is the part that you missed?
Yeah, because
Yeah.
from the velocity to the position function,
Yeah.
I firstly use the general integration, but
Yeah.
I mean general antiderivative, but my elder brother told me that you can just set from the interval 0 to the 5, and we don't need to plus c, and we just need to calculate that.
Yeah, you need the plus c from there. Yeah, so that's it.
Okay.
I have a question about number 5.
Problem 5. Okay.
I just forget what the definition of a derivative is.
Okay, let me actually go and from 5. So f of x is this. Use the definition of the derivative to state that. So that's when it says definition of derivative, that's the limit definition. So you're going to do f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h. So that's the definition it's talking about. And so now if your f of x is x squared plus that guy, so this would look like, so it says also state the definition as part of your answer. So you would actually state this. That's a part of the answer here. But then you have to go and compute it. So replace all x's with x plus h. And subtract the function, which you put in parentheses. And right here, to make things a little bit nicer, I would actually separate these into 2 limits because the 2 different strategies would work nicely on this. So this is x plus h squared minus x squared over h. And then I would put plus the 1 over 1 minus x minus h minus 1 over 1 minus x over h. Because for the second one, the way I would want to do that is multiply top and bottom by the LCD. And I don't want to make the first part, the squared part, any more complicated. So I'd actually split those up. So this will be x squared plus 2xh plus h squared minus x squared all over h. And for this one, 1 minus x minus h minus 1 minus x all over h. I would actually multiply and divide that by 1 minus x times 1 minus x minus h over 1 minus x times 1 minus x minus h. So now in the first one, the x squares cancel. I'd also be able to factor out an h and cancel the h's. And so this would become 2x plus h plus over here, this denominator gets canceled. I would be left with 1 minus x minus 1 minus x minus h all over h times 1 minus x times 1 minus x minus h. This is 2x plus h, and the top part here, this numerator here, is going to be, well, 1 minus 1, that's going to die, minus x minus a minus x, and then it'll just be, I'll just left with h on the top. So that actually cancels. And so I'm left with 1 over 1 minus x times 1 minus x minus h. And at this point, no division by 0 will happen if I plug in h equals 0. So that leaves me with the final answer. And I mean, don't really need parentheses here. So that's your derivative. Yeah. So that's the definition of the derivative. Something you need to know, memorize. All Cal 1 students need to know the definition of derivative. But then after that, it's plugging in an algebra to simplify. So I guess that worked through your question.
Yeah, it was good. Thank you.
Okay.
Can you go through the 1A and 1C? I want to make sure the answers.
1A
and 1C.
and right, let's go through 1A. Maybe you should tell me what you tried.
I used the power rule and the chain rule.
Mm-hmm. So the first part becomes what?
It should be the 12 times. Yeah. 12 times 2x cubed minus cosine 7x square times 6x squared plus sine 7x times 7. It
Yes.
should be the first part.
That's the first one. That's
Okay.
using the chain rule. Yeah.
Yeah.
And then?
And then still use the power rule, right? We can use the power. So minus 7/3 times 3 minus x squared to the power of negative 4/3 times negative 2x.
Yes.
That's it.
And that comes from just thinking of the second part, so that others would see it more clearly. You just rewrite the second part as 3
Yeah.
minus x squared to the minus 1/3. So you bring that minus 1/3 down to the front, that gives you the minus 7/3, and then you subtract 1, which is subtracting 3/3, minus 1/3, minus 3/3 is minus 4/3, and then the chain rule says you have to multiply by the derivative of the inside. So yeah,
Yeah.
and that's fine.
Oh, okay. So we don't need to simplify that.
No, I don't think the instruction said simplify.
Okay, cool.
And 1c, after that, how did you do that one?
Still use the so the negative. The natural log u should be the u prime over u, right?
Yeah.
So the root e to the power of x over 2x plus 1 is u. So we just need to find the u prime.
Okay, that's the harder way to do it. Anyone see an easy way?
Use log rules.
You apply the log rules first, right? So this can be written as 1/2 ln of e to the x over 2x plus 1. Or in other words, I can even break that down further. 1/2 ln of e to the x minus 1/2 ln of 2x plus 1. And of course, e to the x is just, well, that's just x. So this is x over 2 minus 1/2 ln of 2x plus 1. And at this point, I would use the u prime over u thing for the second part. So now my y prime is just going to be 1/2 minus, well, 1 over 2x plus 1 times 2. That's u prime over u times the 1/2. So it's 1/2 minus 1 over 2x plus 1. So if you went and just taken the u as the radical of e to the x over that, you'd have to use the chain rule with the quotient rule. It's kind of annoying. You have a logarithm, use it to your advantage.
Okay.
One of the nice things about the logarithms is are those 10 properties that I gave you guys that allows you to simplify things. In fact, remember, there's a whole method called log differentiation, which kind of shows you when you have something that's very complicated to differentiate, you might even introduce a logarithm that wasn't even there before, just to make the problem simpler. So if the logarithm is already there in the beginning, use it to your advantage. You have these rules that can break things down for you.
Okay.
So yeah.
Also go over 1D.
1D. Okay. All right. Maybe someone give me the ideas for this one. How do you differentiate x raised to the x squared power?
I wanted to make x squared equal to u, but I didn't know how that would work with the secant x.
But what would making the x squared u accomplish? So if you had to differentiate x to the u, how would you do that?
I guess you still wouldn't be able to.
You're right, because you know a power rule where the power has to be a constant. The power here is a variable. So how do we deal with that?
We can rewrite x to the power of x squared
As?
E to the power of ln s to the x squared.
Right. So there's the logarithm again. You introduce it to make your life easier. That allows you to write this as e to the x squared ln of x. And so now you can do the derivative. It's the derivative of the power times the original function. That's how you differentiate an exponential. Derivative of secant, what is that?
secant x times tangent x.
Right. Now in the power here, it's product rule. So you differentiate the x squared, leave the ln, plus you leave the x squared, differentiate the ln. And so this here is 2x ln x plus x. And of course, e to the blah, 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 that's just another way of writing x to the x squared plus secant x tangent x. So again, when the power is a variable, use logarithms. You can either do log differentiation or you can rewrite it as e to the ln of the thing.
Okay.
And so that would actually make it. We should do that. So that's how I would do that one.
Can you go through the 3b and 3d?
Three B.
Yeah, and 3d.
Okay, let's start with B. What did you try?
Is this using the specific trig rule?
The special trig limits, yeah. You
Yeah.
could do it that way.
Yeah. So we can separate it to x over sine 2x times sine 3x over 1 times 1 over tangent sine x 3x.
Mm-hmm.
And so first part we can times for the both side, for the up and down, times
Yeah.
2 for the both.
2 and 2.
And
Here.
second 3x.
And
That
same thing for
part,
this.
yeah.
And then you'll realize that this part here is going to go to 1. This part here is going to go to 1. And this part here is going to go to 1. And so you just have a half times 3x times, well, 1 over 3x.
Yeah.
So those guys cancel. So the answer is the half.
Okay.
Moving down to 3D. So this is, yeah, what did you try for this one?
Me?
Yeah.
Just times the root 4x plus x squared minus ix divided by the same.
Right, multiply and divide by the conjugate. And so in the top, you get 4x plus x squared minus x squared. So those two guys are going to cancel. And in the bottom, you would have the radical of 4x plus x squared minus x. And you would be able to
Factor out.
factor out, say, an x squared from here.
Yeah.
So this is 4x. So you'd have the square root of x squared times the square root of 4 over x plus 1 minus x. Now, this part here, the square root of x squared, this is the absolute value of x, and this is equal to negative x when x is negative. And x is negative since we're letting x approach negative infinity. So now what happens is that part gets replaced with negative x. Right? And so now what you can do is you can factor out an x from the denominator, and you'd be left over with negative, or factor out a negative x if you want. And you'd be left over with the radical of 4 over x plus 1 plus 1. You'd be able to cancel this with that. And so now when you let x go up to infinity, this part here would go to 0.
Yes.
So you just end up with minus 4 over 2. So minus 2 is the answer.
Okay.
Was that what you got?
A little bit wrong. I just directly factor out the x. I don't consider the
Yes.
absolute value.
So that's a trick there. So this was I'm sorry here. It's worth 3 points. Like to miss the negative, I would have deducted a point here.
The whole point, or just
it's
one?
worth 3.
Yeah, I know.
Yeah.
So you will deduct the 3 points if I do not factor out negative.
No, if you forgot the negative, I would deduct a point.
Okay.
So you'd get 2 out of 3.
Okay.
Yeah. So you have to be very careful there.
Yes.
Because the square root of x squared is always going to be, so you're factoring out an x squared from a radical, and it's an even radical. You have to be aware that it's always going to be a positive result. So it's really functions like an absolute value.
Yeah. Can you go through the 7b?
7. Seven. So the average value. So
have you teach that?
Yes, technically, yeah. So
like
this is in the lecture 38 or 39, I want to say. So this says it's a formula. So the average value of f of x on AB, this is equal to 1 over b minus a times the integral from a to b of f of x. So that actually gives you the mean value of a function. So it's like you took an infinite number of y values, divide by the number of y values there are, and what would be the average value? That's it. So in this case, it's x cubed. So here, it's going to be, well, 1 over b minus a times the integral from a to b of the function x cubed minus 3x plus 2. And you just compute that integral, which then is just using the power rule.
Okay.
And I mean, it's an odd function. It's a balance interval from -2 to 2. So the odd functions are actually going to give you 0. So you can even ignore those and you just worry about the even ones. So this is 1/4 times the integral from -2 to 2 of 2 dx. And so that's 1/4 times 2x. So you're going to get 1/4 times 4 plus 4. So the average output is 2 on that interval.
Okay. Okay. I remember that.
Yeah, so this is the formula for average value.
Cool.
Absolute extrema, you do the closed interval method, find the critical points, test the endpoints, pick the biggest y value, that's your absolute max, smallest y value is your absolute min. And for the first one, you just take the derivative and set it equal to the average rate of change and solve for the output. So for this one, you're going to set f prime of c is equal to f of b minus f of a over b minus a, solve for c in the interval. And then how you know it applies because of continuity. Well, you have to do it a little bit more than that because it's the mean value theorem. There are a couple. Applies since f is continuous on AB and differentiable on the open interval AB.
Okay.
So that's how you would say it would apply.
Okay.
Can you go back to the previous problem really fast?
This one, the limit problem?
Yeah, that one right there.
Okay.
I just need to write something down. Can you scroll down just a little bit?
Yeah, so we multiply and divide by the conjugate, multiply it out, we got this, the x squares cancel. And what we did here was we factored out an x squared from under the radical. So we have this here. Then we realized that the square root of x squared is just another way of writing absolute value of x, and absolute value of x returns negative x whenever your x is negative. It's negative because you're approaching negative infinity. And so we replaced it with negative x here. And once you simplify, cancel the common x's, plug it in, you get -2 as the answer. Which
Did you do 2b yet? It's the integral.
hold on, I'm checking something here.
Okay.
I don't think I did 2b, but I also want to show you guys something, because if you want to practice extra problems, like I went over something today and you realize tonight that you still feel a little shaky on it and you want to practice extra problems. So you should be able to see this. This is Symbolab. So this is one of the websites I recommended in the in the syllabus. And this one is nice whenever it can actually compute something. Wolfram Alpha can actually compute more than this guy can compute, but whenever this can compute something, which it can compute a straight up limit or a straight up integral, you will be able to see the steps. So it tells you even the steps. So multiply by the conjugate. So it tells you to do that, and you can show steps, and it'll simplify it for you. And then where does it go? Right. So now here it's like factoring out the constant, factors out the 4, and then it factors. So it does the same thing now here where you factor out the x. Now it doesn't really say where the negative x comes from, but hopefully you'd recognize that it's negative here because of the absolute value. So it factors it out, and the computer realized to put negative x because you're approaching negative infinity. And so yeah, it eventually works down to the answer of -2. So I wanted to show you guys that. So in case you want to do any extra practice and I'm not around, because I have finals today and some other classes. So, but you can check your answers through Symbolab or Wolfram Alpha. If you can get it to work through Symbolab, then it will be, you can actually get it to show you the steps. Now, I don't even think we did any problem 2. So I know you came in a few minutes late. We did problem 6, we did problem 5, we did some parts of problem 1. We just discussed a lot of problem 7. So problem 2 part what?
B.
To be or not to be? Okay. Boom. All right, so let's go. Okay. Maybe tell me what you tried. What do you want to try here?
I was trying U substitution, but I
Yeah.
didn't get
What
very
did you
far.
substitute?
The under the radical, 3x squared plus 2x minus 4.
So your du would be 6x plus 2 dx. All right. And what do you do with that?
I solved for dx. And then this is where I got stuck.
Okay. Maybe I'll show you something and it'll kind of clear things up for you. This might help you get unstuck. So this is 6x plus 2 dx, right? Notice that I could factor out a 2. Is that clear of your confusion?
Yep.
Yeah, so I that's the thing. Just factor out a common 2. So now when you go back and you plug it into this integral, you'd have that 3x plus 1 times the cube root of u times du over 2 times the 3x plus 1. And of course, the 3x plus 1s would cancel. And so it's just like you can factor out a half.
Okay.
So this will be a half times the integral of u to the 1/3. And so this will be like 1/2 times, add 1 to the power, it's 4/3 divided by the new power. What was this? A 3x squared plus 2x minus 4. So that would be that guy.
Sorry, could you scroll down a bit?
I have a question for tomorrow final. So do we so we'll start the exam still at 9:15 because the test will start
Yeah,
at 10.
it'll open at 9:15 a.m.
Okay.
And it will then, so the official start time is 9:30, but I'll give you guys an extra 15 minutes right off the bat, just in case, you have internet issues and you need to restart or something. And then you would have 2 hours and 15 minutes. So from 9:30, that should bring you up to 11:45. And then you have another 15 minutes to scan and upload your answers.
Okay.
One problem per page. So, problem 1 on one page, problem 2 on another page, problem 3 on another page, so on. And just upload them in order.
Okay.
And so by noon, you should be out of there, or maybe even earlier, because technically you guys are getting an extra half an hour to provide for scanning and technical issues. So you might even be able to finish like before. But yeah. But yes, it will open 15 minutes early at 9:15.
Mm-hmm.
If you have no computer issues, you can log on quickly and all that good stuff. You can even show up at 9:30 and it should be fine still. But 9:15, if you want to just get a jump start on everything,
Okay.
it'll be live. Yeah, so we ran through some of these. As I mentioned, you want to do extra practice problems on anything of this type. You can just go to the section textbook or look up random problems online that have to do like these, and then you can check your answer with Symbol Lab or something. Or Wolfram Alpha, or practice the odd problems, and you can see the answers in the back. We have like another 10 minutes or so. Any other questions or concerns?
Can we go over 2D?
2D. Ideas on this one, quickly?
You could do U substitution.
Yeah, what did you substitute?
Sine x.
Yeah, U equals sine. Your D would be cosine. And so you would have your dx. Have your dx is equal to du over cosine x. Also, I could probably just change the limits here. So when x equals pi over 2, your u would be equal to sine of pi over 2, which is 1. And when your x equals 0, your u would be the sine of 0, which is 0. And so this integral becomes the integral from 0 to 1 of 3 cosine x over u squared plus 1 du over cosine x. Of course, here the cosines cancel. And so we are left with 3 times the integral from 0 to 1 of 1 over u squared plus 1. And what's the integral of 1 over u squared plus 1?
Arctan.
It's arctan. So this is 3 arctan 3 arctan 1 minus 3 arctan 0. Arctan of 0 is 0. Arctan of 1 is pi over 4. So you get 3 pi over 4.
So you don't substitute sign in when you solve for, when you get arctan?
It depends. If you change the limits, then no, you don't have to. But if you want to plug in the original 0 and pi over 2, if you don't change the limits, then at this this shouldn't be an x. This should be a u. And then at this point, I would plug in the sign for the u, and then plug in the old limit. But if I change it, I change the limits. So these are u limits now. So that's why I didn't have to go back to the sign.
I don't understand the changing the limits thing. I don't remember seeing it in a lecture video, and I emailed you about it, but I don't know.
I didn't see that email, but it's definitely in the video. I definitely did that. And you don't need to do it. So I just mentioned the alternative. When you have 3, if you leave this as x, which I would write x here to remind you that you are not in use. You could have gotten here just as before, and then you would have 3 times arctan u between x goes from 0 to pi over 2. And so since this is an x, you just plug in back the substitution. So it's arctan of sine of x between 0 and pi over 2. Then you'd plug in the sine of pi over 2 minus 3 arctan, plug in the sine of 0. And so sine of 0 is 0, sine of pi over 2 is 1. So this whole part here goes to pi over 4, and this whole part here goes to 0, and you get the same answer as before.
So with changing the limits, you just don't
You don't have to go back to x's. Yeah.
Okay.
So I'm changing the numbers so that I can plug it directly in u's. So in my x is pi over 2, my u is 1. So plugging in u is 1 and plugging in x equals pi over 2, these are equivalent things. So I can just use my substitution equation to change the numbers on the integral. And it's largely optional in a problem like this. There are situations in calculus 2 where I would say changing the limits is definitely better. But in Calc 1, it's really optional. You do whichever way you prefer. So you can make sure your answer goes back to the original variable, goes back to x's, and use the old numbers. Or you can change the numbers using the original substitution equation and then just plug in those numbers into the new variable. And either one is valid, either one is fine. And yeah, so that would be that.
I have one more little bit question for question 10. So do we need to write a process very specific, or just
question 10?
Yeah, the sketch the graph.
Question 10 is the linear approximation. Do you mean 11? Sketch the graph?
Oh, yeah. Because there are 2 linear approximations in the mock final. Yeah, I mean question 11, the sketch the graph.
Okay, so in terms of, so for 10, you are going to use f of x is approximately equal to f of a plus f prime of a times x minus a, where your f of x would be the cube root of x. You would choose x equals 8.01 and you would choose a equals 8.
Yeah.
And that's linear approximation. Now for this one, you don't have to go to the steps in order, but make sure that you, I think the order that I gave you in the handout makes sense to do it in that from like a conceptual standpoint, but you don't have to do it in order. But
I mean,
make
yeah.
sure that you do box all items required. So whenever you find the domain, make sure you draw a box around it. Whenever you find the asymptotes, draw boxes around them. So I can know that you're hitting all the points. So even if you don't do it in order, just make sure that you're indicating, okay, this is my answer for this part. This is my answer for that part. This is my answer for that part. And then do the graph.
And so, I mean, such as for the intervals of increase and decrease, do we need to write very specific process? I mean, more detail, or just randomly to write the answer?
I'm not sure what you mean, but let's look at the intervals of increase and decrease. Like for that situation, I would say there's going to be a section, and I believe if I recall correctly, this would be section 4 in the handouts. Increasing, decreasing, max and mins, you can find those all from the same situation, right?
Yeah.
So 1, you'll set f prime equals 0 or undefined. This gives you critical points x equals 0. It also gives you critical points x equals plus or minus 2. You would draw a number line. You would put the 0, minus 2, plus 2, and you would test these in the first derivative. Now in the first derivative, the denominator is a square, so really the top controls everything. And so when my x is negative, my derivative is going to be negative, and when my x is positive, my derivative is going to be positive. So you can identify this guy right away as a minimum. And these guys, the 2 and minus 2 are nothing. In fact, these are vertical asymptotes occur here. And so for the increasing, decreasing section, you would say increasing on 0, 2, and 2 to infinity. And then you'd write decreasing on minus infinity to minus 2 and minus 2 to 0. And you would box that. So in terms of increasing and decreasing, that's what I would say. And then you would, you could even put this in the same box actually, but you could say something like maximum, there are none. And for the minimum, this occurs at 0, comma, and then you go to the original function, you plug in 0, and it looks like we're at minus a quarter. So in terms of the work you'd have to show, showing this is good enough for me.
Okay, gotcha.
Yeah. So, I mean, you don't like for example, like I'm skipping the steps here, right? So I didn't actually show me solving the equation, but it is something that you should be able to just look at that and tell what the answer is. Like I'll take your word for it that you know how to do that. You know, so solving an equation like that, it's algebra and pre-calc, so you don't have to show that. But I do want to see a thought process. I want to see the fact that to do this, you considered the derivative, you considered where it's 0 undefined, you found the x's, you tested the intervals, and then you came up with a conclusion, right? Okay. So I can see your thought process here. Now, as for the fine minutia of the details of you actually solving an equation, like I probably don't need to see that. Especially if you can do it in your head at this point, I would just do it in your head.
Okay.
So, and especially with problems like these, like the curve sketching problem, as you remember, these problems are very long. So I don't expect you to actually be writing out like every little line, because then it'll take you forever. It'll take you like 3 pages. So to get it to fit on like 1 page, you know, you write enough for me to be able to see your thought process. I know what you thought of first, what you thought of second, how you came up with the conclusion, and boxed your answer.
Got you. Okay, thank you.
Mm-hmm. Well, hopefully that was helpful. If you have any short, quick questions, I guess you guys can email me. I'll be looking out at my email tonight. If you want to practice more problems, like I said, Symbolab could be of great help. I'll actually be in and out of classes and finals today, so I can't really say I'll be able to respond very quickly, especially if you're emailing me at any point before 8 p.m. today. That's kind of when my day is going to wrap up today. But I have another review to run into, so I am going to let you guys go. Hopefully that was helpful. If you went through the review, again, the final is going to be very similar. I'm not going to like throw any surprises or curveballs here. So whatever topics and problem types you see, those are what's going to come. So if you, the only variation that could happen is within the topic. So if I have, let me say like a specific example. So yeah, so in the related rates problem here, for example, on the test, I asked about a circle increasing. Well, I could ask you any related rates problem. I could ask you that ladder leaning against the wall problem or something like that. But once you see an optimization problem in a certain position or a related rates problem, I'm going to ask you a problem like that. So when it comes to things like that, I would definitely say you should know the steps to solve these problems. And when it comes to the computational problems, make sure you actually know the formulas. So yeah.
Okay.
All right. So I'd say good luck. It should be fine. If you guys actually studied and went through all the reviews and things, I don't anticipate any issues for you guys. I think you guys will be fine. So I will let you guys go and good luck. Make sure to get a good night's sleep tonight. Try to get something to eat before the final tomorrow. Probably not coffee though, because you know you don't want to have to stop to go to the bathroom in the middle of it. So get a good night's sleep so you're not tired. You wake up alert, and yeah.
Thank you.
All right. Take care, guys.
Thank you.
Okay.
All right. Cheers. Bye.